All right, so today the focus is going to be tangents. So we're still looking at the circles. What we're going to start getting into is the angles that are formed. For now, they're just going to look at the tangent line in regards to the length of that segment to the circle, and then we'll get into the angles in the next couple of sections. So a tangent, anytime you see the word tangent, this is going to be a line that's going to touch your circle at one point, and then that point we're going to refer to as the point of tangency. Okay, so anytime you see that word point of tangency, know that it's hitting your circle at that one specific point. Okay. Now, there can be common tangents. This just means that it's tangent to both circles. So if we have a common tangent, your tangent is touching your circle at one point and then touching your other circle at one point as well. And it can be in different spots, right? That one's in between, but more at an angle. How many common tangents do y'all think we would have on these two circles? Where can I draw a line that would touch both circles at just one spot? At the top, all right, so on the outside coming down. All right, anywhere else? On the bottom, anywhere else?
Can you go through the circle?
Can't go through the circle. The problem with if we were to go through the circle is if I try to touch the big one once, let's say I try to touch it there, how many times did I touch the small one? Twice, and that would be considered a secant. A secant. It's a different line. We'll get to those here in a bit. So right now we're just looking at the common tangents, right? So that would just be, we'd only have two lines, two common tangents. All right, sometimes they'll have two, sometimes they'll have three, sometimes they'll have none. This one has two common tangents. All right, what about the next one? How many common tangents do you think B has? Where can I draw common tangents at? Through the middle? Through the middle, like the one up here on the left or the one on the right? The one on the left? Okay, we can do that. In the middle, like the one at the top left. So there's one common tangent. Where else can I draw it? The other way? All right, anywhere else? Top at the bottom. So like the last one? All right, so how many times, any more from here? None? All right, so how many common tangents did this one have? 4, so 4 common tangents. All right, what about the last one? Bottom right? So right here? All right, is that touching both circles at one point? That would be 1. Anywhere else? No, because anytime you try to, even if you were to touch the big circle once, if you have it grazed there on that one point, is it going to touch the small circle? So then that wouldn't be a common tangent. It would be tangent to the big one, but not a common tangent to both circles. All right, so this one has one common tangent. All right, I want you to go ahead and try the bottom two. So as I walked around, I saw a lot of us had these two. And then some of you found the third one, which happens to be right here. So this one had 3 common tangents. All right, and then the last one, I saw that everyone had this one correct. It was just the top one and the bottom one. So you should have had one on top and then one on bottom. So 2 common tangents. So the question at the bottom says, what would it look like if I had 0 common tangents? Circle within a circle? So a circle within a circle, like a donut. Okay, that would be 0 common tangents. All right, when you're ready, we'll go over to the right side. So the theorem here on the right side talks about it being a tangent. Now, keep in mind, when we were drawing our lines, we drew our lines up here. Let's say I drew it up here. And I'm just kind of eyeballing it, right? And if I kind of zoom in a little bit closer, you see that I did not hit my circle one time. How many times does it look like I might have hit my circle? Twice, right? So sometimes we have to prove that we have tangent lines, right? Yes, it looks like it's touching it once, but is it possibly touching it twice? So this theorem states that a line is only considered tangent if and only if it's perpendicular to a radius. So we have to have that 90 degrees there. So unless it says it's a point of tangency, if it says it's a point of tangency, that 90 degrees does exist. If we just have a line and we're deciding, hey, is that tangent? We need to make sure that that 90 degrees is there. And with the way we do that using the Pythagorean theorem. So here it says, J to L is a radius of circle J. Determine whether K to L is tangent to circle J. So what we want to prove is we want to prove that this is 90 degrees. And again, we would use Pythagorean theorem. What would be the length of the hypotenuse though? Because it can't be 9, right? Why can't it be 9? Why do you think I said no to 9 automatically? What is asked? The hypotenuse has to be the longest side. So we already have 15 here. So we know it has to be greater than 15. So what measurement do you think is missing here? Another 9? It looks like it might be bisected, but I don't know for sure. Anything else on the diagram that's going to help us there? The radius. What's the radius? 8. So remind you, the radius, no matter where you draw it from the center to the circle, has to be the same. So this is actually 8, giving the hypotenuse a measurement of 17. All right, so now using Pythagorean theorem, right, we have a squared plus b squared equals c squared. What you want to prove is you want to prove that a squared plus 15 squared is equal to 17 squared. So you're going to give me this total, give me the outcome of 17 squared, and we just need to make sure they come out to the same number. Do they come out to the same number? Aiden, give me 8 squared plus 15 squared. Yeah. And then who got 17 squared? What'd you get? 289? All right, so can I say this is tangent?
Yes.
Yes, so we can say yes, J to L is tangent. All right, your justification on your homework, if it asks you why, you would put that these two numbers came out equal. If it's no, then you show me the numbers that did not come out equal. All right, go ahead and try practice 2. It's the same idea. All right, let's look. All right, Kaden, how did you set up your equation, Kaden? How did you set it up? Okay, Jackie, how did you set it up?
25 squared plus 60 squared plus 67 squared.
All right, and then what did you get for the first one? The first set.
4225.
Okay, and the second one?
4489.
4489. So did they come out to be equal on this one?
No.
No. So then we can say that B to C is not tangent. All right, so the next question down here says, and it's coming back to example 2. It says, it's asking, so if we drew a second triangle with vertices J, L, and M, where M is on K to L, would JKM necessarily be a right triangle? So it's saying if I drew an M here on K to L, anywhere on K to L, say I draw it there, and I make a triangle here, would that necessarily be tangent then? What would we have to prove? Using what method? The Pythagorean theorem. So you still have to prove it, and I guess with some it may come out to be, depending on the measurement. Because mind you, as you're moving the 9, you're also shortening that distance outside. All right, so you are making a different triangle there. All right, looking at example 3. I'm going to just do one of example 3, and then we're going to go down to example 4, or example 3C, because 3C is the one I really need y'all to be able to do. It says, find the value of x if point C is the point of tangency. So if it is the point of tangency, what exists on this diagram? If this is the point of tangency, I need y'all to remember that this is always going to be 90. The moment you see point of tangency, or the fact that it is tangent, that 90 degrees is automatically there. All right, so which one has to be your C? The 14, the x, or the 17? The 17. This is just basic Pythagorean theorem, all right? So x squared plus 14 squared should equal 17 squared. All right, someone give me 14 squared. 196. What about 17 squared? 281. Do I add these or subtract them? Subtract them. All right, so x squared is equal to, what do we get when we subtract them? That's after square rooting? What was it before we square rooted? 93. All right. Then you said it's 9.6. All right, 9.6. All right, this one though. Find the value of x if point J is the point of tangency. So again, what's at the J? 90 degrees. All right, and what are we using with these triangles? Pythagorean theorem. Good. So we have x squared plus 12 squared equals. How do I represent the radius here? Because it's the whole line. It's the x and the 8. If I put 2 x's, then these two are the same measurement. If I do 8x, you're doing 8 times that length to give me the whole length. What are we doing? If this was 5, what would y'all do with the 8 and the 5? Add them. It's the same thing. You're going to do 8 plus x, or x plus 8. Doesn't matter which one you pick. Pick one of them. Okay? I'm going to do x plus 8 myself, all right? If you did the other one, though, nothing would be different. All right, from here, I'm going to touch your algebra skills from last year. My kids, don't disappoint me, the ones that had me. All right, so we have x squared. Nothing can happen with x squared. Can we do anything with 12 squared? Yeah, what's 12 squared? 144. Just simplify it. Now, because it's squared, you have 2 of these. Do you remember how to do the double distribution?
Yeah, you just do the x times x, and you x times 8, and you 8 times 8
All right, don't know if you heard Noah. He said take the x times the x. What's x times x?
It's x squared.
X squared. What's x times the 8?
8x.
8x. Then he said, then you take the 8 and you multiply that to everything in the second. That's why it's called double distribution. You're distributing each number to everything in the second set, and you have to do it twice. 8 times x is 8x, and 8 times 8 is 64. Now, had you set up your equation with 8 plus x, then your numbers would just be in reverse. It would be 64 plus 8x plus 8x plus x squared, which is fine. All right, now we're going to combine like terms. What like terms do I have on the right side? The 8x. 8 plus 8 is, all right, we're just simplifying it. All I'm doing is cleaning it up. All right, from here, it's what we've been using all year. Combine like terms. What do I need to move over? What do I need to put together?
The x squared.
Okay, I'm going to do the x squared first, and then I'll do the 64. I did hear the 64. What happens to the x squared? They're going to cancel out. Now, with this problem in our class, in this section, this is going to happen every time. For now, the x squared is just going to disappear. Not disappear, but it's going to cancel out. All right, now we move over the 64, and hopefully we're more comfortable now because we've done this type of solving all year. All right, so 16x is equal. What's the difference of 144 and 64? 80? All right, and then the last step would be to divide by 16. Your x value, your radius, comes out to be what? 5. All right, so with that one done, I'll leave this one up so you can see it. Go ahead. I don't have one for you. Let's go ahead and go over to the back side. I thought I had one for you. All right, does everyone have this one copied all the way through? All right. This was all the hard work. The easier work's on the back. So common tangents. Anytime we have common tangents, these tangents are going to be congruent. They have to have a common external point. So they have to have the same exterior point. The exterior point being on the outside of the circle. When they share that point, then these two tangent lines are going to be congruent. But that's given that you know that they're tangent, right? If you know they're tangent and they share a common point, then these two segments will be equal. All right, so all it is setting it equal. It says A to B and B to C are tangent, so we know they're tangent, to circle D. And they're sharing this B value. What should be true about these two equations? They should be equal. I'm not going to make you solve it. I am going to make you have, I want you guys to set it up. So just set it up because from there you would just solve, okay? All right, same thing here. You have that, I give you that they're tangent. They have a common point of C. So if they have that common point, again, all you do is set them equal. All right. What type of triangle would I make if I was to connect A, B, and C? So coming back to this first example. If I was to connect this to make a triangle, what type of triangle would I make? An isosceles. And if it's an isosceles triangle, you know that this angle would have to be congruent to that angle. All right, just something to keep in mind, right? Something to keep in mind. All right, this one. All we're going to do is do what with them? Set them equal. This one may, some students may take a minute, but just a reminder, this is the same step, the same last step we do every time with Pythagorean theorem. What do we have to do? Square root it. So x is equal to 3. All right. And then let's go over to the last page. All right, so when we talk about a polygon being circumscribed about a circle, we're talking about all the sides of that circle are touching all the edges of your polygon. So if you look at this one, you see how all the edges are touching the sides of your polygon, right? If you look at the one next to it, you see how there's gaps there? Like the circle isn't even in there. Okay, those are non-circumscribed ones. Now, when you do have them, we see that there are common tangents on the outside. So here we have a graphic designer giving directions to create a larger version of this triangular logo shown. If triangle ABC is circumscribed about circle G, find the X and then the perimeter of triangle AB to C. So look, all this is, we just looked on the last page, that if I had a circle and two tangents, as long as they shared a point, that they were equal. It's the same idea here. Take this image and picture it on this diagram. What do we know already? What other measurement can we confirm? That A to E is 8, because these are common tangents. What else can we say then? What's 7? Good, B to F is 7. So he says this is 7, this piece has to be 7. Well, then that allows us to find X, because we know X should be equal to C to F. So how do we figure out what that X is? Just 10 minus 7. You're going to do this piece right here. 10 minus 7 is 3. And if that's 3, then X is 3. All right, and then the only other thing you have to do is find the perimeter. So to find your perimeter, you're going to double your 8s, double your 7s, and then double your 3s. 36. All right, so that was a circle inside a triangle. The next one is a circle inside a quadrilateral. All right, we have quadrilateral ST, oh, I saw him, RSTU inside circle J. Find the perimeter or find the value of X if the perimeter is 18. So what can I put on T to B? What can I put right there? The X. These two are the same. Look, every corner class, every corner, they're going to be common tangents. So what am I gonna put on B to U? Another X, because those two are equal. What am I gonna put on C to R? 3. And what am I gonna put on D to S? 3. All right. So then 3 plus 3 plus 3 plus 3 gives us what? 12. X plus X plus X plus X is how many X's? 4X. And then altogether, we say the perimeter is 18. All right, what's the difference of 18 and 12? 6. So 6 divided by 4 is 1.5.